Hello chemistry students. In this video I'm going to practice predicting the products of reactions. I'll do as many as I can in the 15-minute time limit on the video here. So looking at the directions here, it wants us to classify. We'll have to do that in order to predict the products, and then we'll also write out what it makes. So I'll start off here with the magnesium and the oxygen. Remember, oxygen is one of the diatomic molecules, one of the Brinkelhoffs, so it's O2. Now, notice that both of those are elements. So if we take a peek at our reference table really quickly, that's going to be the formation of a binary compound. Two elements get together and do that. So that will mean that we'll put these together. Magnesium forms this would be an ionic compound. Magnesium forms positive 2 ions. Oxygen forms -2 ions, so they'll go together just like that. To balance it, we would have to put 2's here and here, and this compound would be called magnesium oxide. All right. Now, the next one up is aluminum and hydrochloric acid. So, Al and HCl. So that looks like a metal reacting with an acid. So positive would replace the positive. That would be the aluminum replacing the hydrogen. Now let's look over here at the reference table and see if, okay, so that would be a single replacement. Active metal replaces hydrogen from water. Now how do we know if the metal is active? Well, we're going to look at the reference table. And I'll go back over here for just a moment. Aluminum. So let's find aluminum. Now, can aluminum replace hydrogen from acids? Yes, it can. It's within this range that goes down here. So we'll go over here and do that. So afterwards, the aluminum will be with the chloride, and aluminum is a +3 ion, chloride is -1, so that's the formula. And the hydrogen that gets replaced will be by itself. Hydrogen is a diatomic molecule, so it needs the 2 there. Then the reactants, the balancing of this reaction, I think that we will end up having, so if I do the chlorines, that'll give me an odd number of hydrogens, 3 to go with that. That won't work, so I'm going to try doubling this. Then that would mean I would need a 6 here, 3 here, and a 2 there. That cannot be reduced, so that's right. And also I need to name these compounds. So there's aluminum chloride. And hydrogen. All right. Next up, let's take a look at this sodium chlorate. So there's only one reactant, so that means this has to be a decomposition. Sodium chlorate would be NaClO3. Remember, sodium is +1 and chlorates are -1. So let's take a look over here at the reference table and find a decomposition of a metallic chlorate, and that is this one. So we're going to form a metal chloride and oxygen. So let's go over here and do that now. So here's our metallic chloride, or metal chloride, NaCl, and then oxygen. Oxygen is diatomic. Sodium chloride is correctly written, +1, -1. Now we would need to do some balancing here. So I think 2, 3, and a 2 there will make that work. So we're going to have sodium chloride. All right. And then, let's see this next one up, zinc chloride and ammonium sulfide. They're both aqueous, both Make sure we check our charges on these ionic compounds. Alright, so both of these are compounds with a pair of ions in them, so what they could do is they could switch places with each other. Let's switch them out and see what the products would be if this reaction worked. So it would be zinc sulfide, +2 and -2, so they work like that, and ammonium chloride, NH4Cl, and then to balance, we'd do that. Now, let's check this. We need to make something that's insoluble. So let's check our solubility rules and see if zinc sulfide or ammonium chloride would be insoluble. Go up on this page, find the solubility rules. Okay, so everything with ammonium in it is soluble. So the ammonium chloride would be soluble. That's not our precipitate. However, let's look at the sulfides. See, here's the rule for sulfides. It says all sulfides except group 1, group 2, and ammonium are insoluble. Okay, so zinc sulfide is not in group 1, not in group 2, and it's not ammonium, so that means that zinc sulfide is insoluble. That rule applies to it. And so this would be our precipitate. And I'm just going to indicate that by putting an S here. If I had room, I would put a PPT there to tell me that that's the precipitate. So yes, this reaction does work. And I'll write out, so this is zinc sulfide and ammonium chloride. Alright, here's another one, calcium carbonate. Okay, that's got to be a decomposition because there's only one reactant, so CaCO3. Let's look over at our reference table and see what we're supposed to make. Alright, so in a decomposition of metallic carbonate, it says we're supposed to make a metal oxide and carbon dioxide, so let's do that. So here's our metal oxide, calcium oxide, and carbon dioxide. And that one is conveniently balanced, and calcium and oxygen would combine in a 1-to-1 ratio because calcium is +2 and oxygen is -2. Oh, just realized that I made a mistake here, so let's fix that. It's supposed to be carbon dioxide. There we go. So calcium oxide. And carbon dioxide. Alright, up next we've got some sodium nitrate and some ammonium sulfate. This will be a double replacement reaction if it works anyways, and I've got a suspicion that it does not work. There's sodium nitrate, here's ammonium sulfate. Check your charges on all these things to write the formulas correctly. Alright, if these, so two compounds, so they're probably going to double replace with each other if they can. So it's going to be Na2SO4 and NH4 NO3. So sodium sulfate and ammonium nitrate. Now let's look at our solubility rules and see if we actually form a precipitate. So this says all nitrates, acetates, ammonium, and group 1 salts are soluble. Let's go back over here. Group 1 salts, this one's soluble because it's got sodium in it. This one has ammonium and nitrate. It's very soluble. So this is no reaction. If you don't form water or an insoluble gas or a precipitate, then you have no reaction. All those ions are still just hanging out in the solution. because no solid formed. Okay, let's take a look at the iron and the copper sulfate and see if that one can work. So iron is Fe, copper 2-sulfate, CuSO4. Alright, and this would be a single replacement. The iron would replace copper. Let's check the reference table and see if this will be a metal-metal replacement, like 3A. So let's check that and see if iron can replace copper. So here is iron, and here is copper. So iron is above copper, so yes, iron can replace copper. So let's do that. FeSO4 plus Cu. And that would be iron 2-sulfate and copper. Alright, next up we'll look at the zinc and sulfuric acid. So Zn plus H2SO4. Alright, so that would be zinc replacing hydrogen out of an acid. Let's check the reference table and see if that can take place. Again, that is a single replacement. So that would be an active metal replaces hydrogen from an acid. Let's check the reference table and see if zinc can do that. So zinc, and here's the range, replace hydrogen from acids. Zinc is within that range, so yes, that can occur. So we're going to make zinc sulfate and hydrogen gas. Alright, let's check out the dinitrogen pentoxide plus water. So here's some N2O5. Alright, so what we have here is a nonmetal oxide plus water. That tells us that this is a synthesis type. That's harder for you to see than it will be for me to see, because I've, done a lot more chemistry. But if you sit there and look at it and study for a while, you should be able to figure that out. That's this type. It's going to make an acid. And let's go over here and think for a minute. What acid do we know of that has hydrogen and nitrogen and oxygen in it? Well, it's either going to be nitric or nitrous acid. Let's just go ahead and go with the most common one, which is nitric acid, and see how things turn out. HNO3. And if you study on this for a little bit and you go to balance, you're like, hey, if I put a 2 there, that'll balance everything. So this is going to be nitric acid. All right. Go over here and do a few more if we have time. Okay, so chlorine plus magnesium iodide, so Cl2 plus Mgi2. Now, this would be a single replacement. The chlorine would not replace magnesium. It would replace the nonmetal iodine. Let's see if it can. So again, this would be a halide replacement. The change taking place there. And let's look at this activity series. So we need to know if chlorine can replace iodine. Chlorine is above iodine, so yes it can. So this would make MgCl2 plus I2. Iodine is also a diatomic molecule. So magnesium chloride the name of the I2 is iodine. Alright, this one isn't circled, but I'm actually going to do it too. I'll snap, I'm almost out of time. Let's look at it. I'll pause for. Alright, chlorine would replace fluorine if it could, but let's check the table. Alright, Chlorine cannot replace fluorine because it's below it, so this one is a no reaction. Thanks for watching.